Hey everybody, this is Larry. Hit the like button, hit the subscribe button. Let me know how you doing this problem. I'm gonna solve it live right about now. 617, merge two binary trees. Given two binary trees, and imagine that when you put one of them to cover another, some of the two trees overlap while others are not. You need to merge them with a new tree. The merge rule is that if two nodes overlap, then sum the node values up as the new value of the merged node. Otherwise, the not no node, not no node, will be used as the node of the new tree. Okay. Okay. Let's see. I'm just trying to think a little bit about C++. I think you can do this with a. Also, I'm just trying to think if I could do it in place or if I can just use it. Use Python 3, or do I create a new node? I think I'm just going to create a new root just to kind of make things a little bit easier. Can these be empty? I guess it could be. That shouldn't happen, right? Else. And then now, okay. Left is equal to merge trees of t1.left, t2.left, and the same for the right side. Let's give it a go. I mean, I think the tricky thing about these cases are that sometimes you run into edge case issues. Non-object has no left. I guess that could be a thing. Oof. But let me turn off my sounds. I'm trying to keep it simple as well. I mean, we could definitely, we could definitely kind of add stuff to this, but yeah. I guess let's just do like else t1, just kind of be a placeholder. I'm losing my voice today for some reason, but okay, cool. That's I just submit it. They didn't give us many test cases, so okay, cool. Yeah, I mean, this could have been faster, I suppose, and maybe even use a little bit of memory. I just kind of have a send no case for that reason. I guess actually I didn't need to construct a new one. I could use like a static, send no or something like that. But it's okay. Cool. Yeah, so this is linear time because we look at each node at most once, or at least once, or exactly once, I guess. And space, I guess if I didn't do this little thing, it would have been, well, I mean, I guess it doesn't really matter because we always create a new node instead of using it in place. So it's going to be O of n. So O of n time, O of n space. This is an easy problem. This is a tree problem. I think it's just a natural way to kind of ask yourself about recursion problems. So definitely study it up a little bit. This one's a little bit more tricky, and very often with these kind of recursive / tree problems, Always look out for the edge cases, however they may come up. Course they might. So, and in this case, I handled it by um, setting them up to send no values, but you could have also checked it here, but then that would have made the combinatorial situation kind of a little bit messy to write. But yeah, cool. I think I'm okay with this problem. So yeah.